Every second our sun pours out unimaginable amounts of light and heat. It warms our planet, grows our food, and keeps us alive, but where does all that energy come from, and how does the sun, a giant ball of gas, turn mass into light? The answer lies in one of the most powerful equations in history, E equals mc². In this video we'll explore the incredible science of how the sun transforms matter into pure energy, and why it's possible at all. Let's start with Einstein's equation E equals mc². It tells us that energy equals mass times the speed of light squared. The speed of light squared is a huge number, meaning even a tiny bit of mass can release an enormous amount of energy. But where in the real world does this happen? Answer: inside the sun. It's the most powerful mass-to-energy converter in our solar system. And it does it every second of every day. The sun isn't made of fire. It's made of plasma, a superheated gas of particles, mostly hydrogen atoms. These hydrogen atoms are constantly crashing into each other under extreme heat and pressure. In the sun's core, the temperature reaches over 15 million degrees Celsius. That's hot enough to force hydrogen atoms to fuse, meaning they combine to form helium. But something strange happens during this fusion process. When 4 hydrogen atoms fuse into one helium atom, the new helium atom weighs slightly less than the 4 hydrogens combined. That missing mass? It doesn't disappear. It turns into energy. Just like Einstein said, mass becomes light, mass becomes heat, mass becomes the sunlight we see and feel on Earth. This process is called nuclear fusion, and it's what powers every ray of sunshine that's ever touched your skin. Let's break it down. The sun converts about 600 million tons of hydrogen into helium every single second. Out of that, 4 million tons of matter vanish and become pure energy. Yes, you heard that right. Every second, the sun turns 4 million tons of matter into light. That energy travels across space at the speed of light and takes about 8 minutes to reach Earth. It's enough to power our entire planet, and then some. You might ask, why can't we do this on Earth? Well, we're trying. But the conditions in the sun's core are extreme, far beyond what we can easily create. It's the intense gravity and pressure in the sun that allows fusion to happen. Without that, hydrogen atoms can't get close enough to fuse. Still, scientists are working on fusion reactors, machines that mimic the sun, and hope to one day generate clean, limitless energy using the same principle. Until then, the sun remains the original master of E equals mc². So what happens to the energy once it's created? The energy produced in the sun's core takes thousands to millions of years to reach the surface, bouncing between atoms inside the sun. Once it escapes the surface, it races through space as light and heat. Some of it warms your face, some grows your food, some powers solar panels and gives life to entire ecosystems, and all of it began as a tiny bit of mass lost during fusion. Let's bring it back home. Without fusion, there'd be no sunlight, no photosynthesis, no warmth, no gravity to hold the solar system together. You are, quite literally, alive because the sun converts matter into energy. Even the food you eat is sunlight, stored in plants, which are powered by the sun's rays. Every movement you make is borrowed energy from lost hydrogen atoms. It's important to understand that fusion, what powers the sun, is different from fission, which powers nuclear reactors on Earth. Fusion joins atoms together. Fission splits atoms apart. Both release energy by converting a tiny bit of mass into energy, via E equals mc², but fusion is cleaner and more powerful. It's what makes the stars shine. And someday it might be what powers the future of humanity. So the next time you look up at the sun, remember every beam of light you see was once mass, matter that disappeared, and became pure energy. It's the most elegant magic trick in the universe. And it's all explained by a single, beautiful equation, E equals mc². From the heart of the sun, to the light in your eyes. That's the power of turning mass into energy. And it's happening, right now, 93 million miles away.